Next question. Discuss in brief about singly linked list. Linked list can be defined as collection of objects called nodes that are randomly stored in memory. Unlike an array, linked list does not store the data in a contiguous memory location. We use the dynamic memory allocation to store the values into a piece of memory called node, where the node contains two parts. One is the data part or the value to be stored, and second is the address of the next node or the reference of the next node. The last node of the list contains pointer to a null pointer to indicate that the list has ended. Here you can see a small diagram showing just 3 nodes. The list is always identified by the first node, hence we store the address of the first node into a pointer called head or sometimes start. We can see that each node is having a value and a reference to the next node. The last node is referring to either null, or here this is a snapshot. So here you can see that only 3 nodes are present. Actually many nodes can be there, unlimited number of nodes can be there. Some people refer the last node using a special kind of pointer called tail. This is not required, but in case you directly want to traverse to the last node, you might use this one. These things have been discussed already. Empty node cannot be present in the linked list, and we can store values of primitive types or objects into a linked list. Just like an array, we can have any kind of data type stored in a linked list. What is the reason why we have to use linked list over an array? We already know that array is a static data structure, and even though we can implement array using malloc function, once that memory is completed or full, you need to extend the memory in an array using a realloc function. So you need to copy all the contents from the old array into the new array in case the memory is full. However, that disadvantage is not present in a linked list. A linked list does not have a memory full condition unless otherwise the main memory is completely full. Because this question is asking you to discuss in brief, you don't have to write any algorithms or explain all the operations on the linked list. You could additionally explain about what is the time complexity taken to search a node, what are all the various operations that can be performed on a linked list, such as insert, delete, traverse, etc. So in array we should know the size in advance, but in linked list we don't have such a need. We can keep adding at the runtime whenever we are required to add a new value. So these are mostly discussing about advantages and disadvantages or comparing a linked list with an array. These are not required, but you might want to go through them just in case they ask you to compare a linked list with an array. One more point to remember is there are 2 kinds of linked list. One is a singly linked list and another is a doubly linked list. A singly linked list will traverse only in one direction, that is from head to tail, but in a doubly linked list you will be able to traverse in forward as well as reverse direction.